Welcome back. I need to push on a little bit on these quantities that we're talking about, speed, velocity. I'm bringing in another one, acceleration. Acceleration is the rate at which velocity changes. Therefore, acceleration A should be given by change in V over change in T, okay? Now, if V is changing, obviously you would say acceleration should be moving from V initial to V final. So that change will be given by V final minus V initial over delta T as well, which will be T final minus T initial as well. But we normally just take the duration of time there. Acceleration is a vector quantity just like a velocity, and therefore it has got both magnitude and direction, okay? Acceleration on an object can result in either an object speeding up or slowing down. So even when it's slowing down, it's not deceleration, it's acceleration in the negative direction. So you must understand that, okay? And quickly, an airplane moving from rest takes 18 seconds to reach a speed of 68 meters per second. What is the acceleration of the plane? Now, acceleration is change in V over change in T, which will be equal to V final minus V initial divided by change in T. That should be equal to the final, it's 68 meters per second, minus it takes off from rest, okay? If it is taking off from rest, it means the initial velocity was 0 divided by what is the time that it took to accelerate up to that level? 18 seconds. Now, what is the answer here? We can quickly find it out. 68 divided by 18 here, and then we find it to be the acceleration to be 3.78 meters per square second. The unit of measurement for acceleration is meters per square second, okay? Now moving on, linear momentum, okay? The momentum of an object is what we call the product of mass and velocity. Now when we say product, we mean these two things, mass and velocity, should be multiplying each other. Therefore, momentum, which is symbolized by small letter p, equals to mass times velocity, okay? Now, the unit of measurement is the kilograms meters per second. I think we can see it from here because mass is measured in kilograms times velocity is measured in meters per second. So you have the unit there to be kilograms meters per second for momentum, okay? And we also need to know that momentum is a vector quantity, so it must be expressed in both magnitude and direction. Okay, example here, let's have a look at it quickly. An athlete of mass 65 kilograms runs at 2.5 meters per second towards the east. What is the momentum of the athlete? Momentum P, it's mass times V, so that should be equal to, what is the mass? 65 times the velocity, 2.5 meters per second. Now I am literally assuming that my velocity towards east, I'm taking it to be positive here. Towards east is positive, and hence I have it as positive there, okay? And what will that be? Quickly we can get that. 65 times 2.5, what is the answer? We get it to be 162.5 kilograms meters per second. That is the momentum of the athlete as he runs towards the east, okay? Change in momentum. All right. Now, change in momentum of an object is found by subtracting initial momentum from the final momentum. Now, obviously, that should give us change. If we're talking about change in something, we should find the final value and the initial value, subtract the initial value from the final value. Whatever we get there is the change in that particular quantity. Now, let's have a look at it. If we're talking change in momentum, if P is momentum, change in momentum will therefore be delta P, because the word or the letter delta here, symbol delta, they symbolize change. So delta P will be equal to P final minus P initial. Remember that momentum is mass times velocity, so the final momentum should be mass of that object times the final velocity of that object, which is what we have there, minus the mass of that object multiplied by the initial velocity of that object, okay, which gives us initial momentum. Now, if we check here, you would see if we're looking at the same object, we've got the same m there. So mathematically, we can factor it out, we can factorize it out, and we've got m into v final minus v initial. So that gives us that change in momentum. Let's have a look at an example here. A car of mass 1400 kilograms is traveling at velocity, so initial is traveling at 72 kilometers per an hour, okay, along a straight road. The driver applies brakes and slowed down the car to a velocity of 20 kilometers per hour. So V final equals 20 kilometers per hour, okay? But we don't work in kilometers per hour, we work in meters per second. Now, I don't have much time, but know that if you want to move from kilometers per an hour to meters per second, you divide by 3.6. I will show you one day how you arrive at that. 72 divided by 3.6, that gives you 20. So this is 20 meters per second. And the 20 kilometers per hour divided by 3.6, that gives us 5,56 meters per second. That's also meters per second. So you can calculate for the change here, making use of the formula that I have shown you now. We will start from here in the next section.